Okay, let's try out an example now of this crazy cone-ish shape. Now, like usual, I'm not going to leave you on your own for this first one. We'll do it together. And all we're given is, well, one, the shape. We have this equation. Two, we know the density. It's 5 slugs per foot cubed. And we want the maximum of inertia. So how are we going to do this? Well, we're going to have to figure out what kind of shape we're going to use, which in this case, we'll use a disk element. And then we're going to set up our equation for the element or the um, infinitesimal moment of inertia for that disk, and then integrate. So let's jump in there and try it out. So first off, the best thing you can do for any of these problems is to draw your disk element, because you'll instantly figure out what you need to know. Okay, so for this disk element, I need to know the area of the top, as well as its thickness. And well, the thickness, that's dy. That's dy. Now, what is the area of that element? Well, that's going to be equal to, well, this is distance x to the edge. And so the area would be pi r squared, which is going to be pi times x squared dy. Now, the issue we run into then is, well, when we start setting this up, we set up our equation here that, our diy is going to be equal to 0.5 times that infinitely small mass times x squared. Okay, we know that we're good so far. We have to find the differential mass. That's simply going to be equal to my density times my volume element. And that's going to be equal to the area times the thickness. But still, we've got an x there, and we're integrating in terms of y. How we get rid of it? We use the equation. If we go back to the beginning page, we see that y squared is equal to x. And so what I do then is I say, okay, well then x squared is going to be equal to y to the fourth. X squared will be equal to y to the fourth. Wait. Sorry about that. Y is equal to x squared, correct? Let me make sure I check that back there. Nope, I had it right first time. I'm being crazy. Okay. So x squared would be equal to y to the fourth. Okay. So we bring it out and we start looking at everything and say, okay, do we have everything we need? Do we have everything we need? And we check and say, okay, let's look around. Well, we have x squared right here. We have x to the fourth. Wait a minute, what happened? That's simply because we had dm, which has x squared in it, times x squared. So that's why we have x to the fourth right there. So if x squared is equal to y to the fourth, then x to the fourth would be equal to y to the eighth. So I plug all that in. This is not a difficult integral, and I can solve. And so what I get then is that it's going to be 0.873 slugs per foot squared. Or sorry, slug foot squared, not slug per foot squared. So it's a crazy shape, but the setup is actually pretty simple. So I believe that's all for this time. It is. So thank you so much for listening, and I'll see you all later. Have a wonderful day. Bye-bye.